Hello and welcome back. We are on day 3 of chapter 11, continuing on with area. We started off talking about the area of square and the area of a rectangle, and then yesterday we talked about triangles and parallelograms. Today we're going to add one more area formula in there, but before we do that, I want to talk about something real quick here at the beginning, and that is the median of a trapezoid. The median of a trapezoid. Now, the median of a trapezoid is the line segment that joins the midpoints of the two non-parallel sides of a trapezoid. It is the median of a trapezoid is the line segment that joins the midpoints of the two non-parallel sides of a trapezoid. So that's saying in our trapezoid, we have our two parallel sides here. And if we look at our two non-parallel sides, we find the midpoint of each of them, and the line segment that connects the two is our median. Now there's a formula to find the median, and that is capital M for median is equal to 1/2 base 1 plus base 2. And in our trapezoid, we're going to have base 1 and base 2. So median of a trapezoid. Now let's jump into our area formulas, or area formula, since we're only going to talk about one formula for today. And you guessed it, we talked about the median of a trapezoid, so we're going to talk about rhombuses today. Nah, I'm just kidding. We're going to talk about the area of a trapezoid. Talk about the area formula for a trapezoid. And that is, the area is equal to 1/2 base 1 plus base 2 times our height. So again, we have our trapezoid here. We're going to have our base 1 and our base 2. And we're also going to need our height. Now, look at our area formula for a trapezoid and see if you notice anything about it. Right off the bat, you probably should have written something down and thought, I just wrote this down somewhere. And if you look up top here, you did just write part of it down. If we look at our first portion of our area formula, we have 1/2 base 1 plus base 2. If we look at our median formula, it's 1/2 base 1 plus base 2. So another way of writing your area formula is area is equal to our median times our height. So either way is correct. One is just simplifying it and plugging the median or the M in for our 1/2 base 1 plus base 2. Now, that's our only formula for today. So we're going to jump into some examples. So our first example for the day here. First example for the day. We're given a trapezoid. Now, We could go about this like we did yesterday and break this up into a rectangle here and a triangle here. But we want to use our area formula for a trapezoid since that's what we're talking about today. So we're going to do that way. So we're going to break this up. We are still going to break this up. And in doing so, what we're looking for is we need the height, which we technically already have here. We know that this is going to be 24. So we know our height's going to be 24 units. But we also need to find our total base here, base 2 here. But we already have part of it now by creating this rectangle because we know that this is going to be 40 units here. Now we just need to find our last little section of our base 2. To do this, by linear pairs, we have a right angle there. So we have a right triangle. So you can use Pythagorean theorem, 24, 25, and solve it down. Or if you know your Pythagorean triples well, you actually know that 24 and 25 is going to give you a last segment or a last side measurement of 7. 7, 24, 25 is a Pythagorean triple. Now we add them together and we get our second base length, or base 2 length is 47 units. Now we can use our area formula. So we have our area is equal to 1/2 base 1, 40, plus base 2, 47, times our height, which is 24. When we solve that down, we're going to get a grand total area of 1,044 units squared. And there it is for example 1 of the day. You got to find a couple of things, solve for a couple of things, and in turn, you will find the total area. All right, let's move on to example number 2 now. Example number 2 right here. Now we're given a couple more side lengths, but we're still missing our bottom length. And in this case, we're given a couple of angle measurements. We're given 60 degrees and 30 degrees. So what I'm going to do is I'm going to break this into a couple of different pieces. So I'm going to break it up like that. Right off the bat, we can immediately find that this little segment here of our base 2 is going to be 10 units. Now, all we need to do is we need to find our height and we need to find our total base length. So the first thing I'm going to do is I'm going to find our height. I'm going to start over here on this one. These should be the same. They are going to be the same because they're both our heights. And in this case, I'm going to find this one. So by linear pairs, I know that this is a 90-degree angle, and 60 and 90, that only leaves 30 degrees up here, and we have a 30, 60, 90 triangle, which means we can use our 30, 60, 90 triangle theorem to find our other two sides. Given that our 12 is here, we know that's our 2x. So opposite our 30-degree angle is our x. So this down here, this little portion of our base 2, is going to be 6 units. Now, to find our height, we have to look at our 60 degree and look at the side opposite of that. That one is our x times the square root of 3. Our x is 6, so we have 6 square root of 3. If we look over at our second triangle here, we also have linear pairs, gives us a right angle there. We have 30, we have 90. Our last angle is 60 degrees. So if we look, we have 12 times the square root of 3. If we look opposite our 30-degree angle at our x, this is our 2x, so our x is going to be 6 square root of 3. Heights are the same. That's good to know. Now we look opposite our 60-degree angle, at our side opposite our 60-degree angle, and that's our x times the square root of 3. So if our x is 6 times the square root of 3, and we multiply that by our square root of 3, our square roots cancel out, and we get 18. Now we add all the measurements up, and we're going to get this bottom base length is going to be 34 units. And from there, we can do our area formula. We have area equals 1/2. Base 1 is 10 plus base 2, which is 34, times our height, which is 6√3. When we simplify that down, we are going to get that this is equal to 132 times the square root of 3 units squared, or you're going to get, in a decimal form, 228.63 units squared. And that's an approximation. That is approximately 228.63 units squared. So there we have it for example number 2. Now we're going to move right along here. And in this example, what I'm going to do is I'm going to give you a little bit of time to pause the video and try this problem on your own. After you've tried it and given it a shot, come back and I will walk through it and you can see and you will get the answer. So go ahead, give it a shot, and then come back and see if you were correct. Okay, now in this problem, we have to find our height, but it's not given over here, and it's not given here. We also need to find our second base length. So I'm going to start with our second base length because we've created a rectangle here, and so we know that that length is going to be 9. So our 8 and our 9, when we add them together, we get a total length of 17. For our base 2, we get a total length of 17 units. Now all we need is our height. To find that, we have a right triangle by linear pairs. We have 8 and we have 10. To find our final side, I see 8, I see 10. I think divide both of them by 2. When we divide 8, we're going to get 4. When we divide 10, we're going to get 5. 3, 4, 5 triangle automatically pops into my head. Head. And so this side over here is going to be a factor of 3. We divided these by 2, so we have to multiply 3 by 2, and we get 6. Now we have our two bases. We have our height. Let's do our formula. Area equals 1/2. Base 1 is 9, plus base 2 is 17, times our height, which is 6. When we solve that down, we get a total of 78 units squared. And that is how you solve that one. All right, moving on to example number 2. We're going to step it up a little bit. We're given an isosceles trapezoid. Again, I'm going to give you some time to pause the video, try this problem on your own, then come back and watch the video to check your work. So go ahead, give it a shot, and then come back to check your work. All right. Now, this doesn't have a whole lot to it, but we do know is we have an isosceles trapezoid. We have a 60-degree angle, so that means that this is also a 60-degree angle. And we are going to create our rectangle here to find our heights, but also we need to find our second base. By creating this rectangle, we find that this portion of our base is 7 units. Now all we need to do is find our height and our other two portions. Now since they are the same, skip that. Let me back up for a second. We need to find our heights. So I'm going to focus on this one over here. I'm going to focus on this triangle over here. By linear pairs, we have a 90-degree angle. We have 60, we have 90, which means this last one is 30 degrees. Now we can find our other two sides. I'm going to go across from our 30 to our x. Since our 2x is 6, our x is going to be 3. To find our height, we're going to go the side opposite our 60-degree angle. That's our height now. To find that, we take our x and we multiply it by the square root of 3. So we get 3 root 3. Since these sides are equal, this side measurement is also 6. And in turn, we are going to get 3 down here. And we're going to get 3 root 3 here. Now we have everything. If we add all of this together across our bottom base, we're going to get a base length of 13 units. And now we can use our area formula. 1/2 base 1 is 7 plus base 2, 13, times our height, which is 3 root 3. When we solve that down, we are going to get 30 root 3 units squared, which is approximately 52 units squared. It actually comes out to about 51.96, bunch of other garbage, so approximately 52 units. So there we have it for area of a trapezoid. Next up, there is a worksheet on Schoology. Give that a shot. If you have any questions, we have office hours, and we will also be available via email or messaging to answer any of your questions or post them in the discussion section. Have a great day.